environments with a lot of different storage needs and a lot of different solutions to those. I've been certified on both DataCore and XIO and several other storage arrays since around 2008, and have all the normal industry standard certifications as well with regards to my Microsoft MCSE, VMware VCAPs, VCPs, things like that. So tend to have a good understanding of not just the storage side, but the entire solution end to end. So as a whole, that tends to make me reasonably capable of talking about this and covering the basis of everybody who would use storage. So let's jump right into it. We're going to start out talking about all-flash arrays. So we've got a poll question here. So what are your current storage challenges? What problems are you running into in the real world? What's your big issues? And go ahead and open that up for a couple minutes, just let people respond, make sure I address those concerns. And while doing that, I'll go ahead and start talking about all-flash arrays. We're starting out here because this is kind of what everybody is extremely going for right now. Everything you go to any convention, everybody's talking about all-flash arrays. They're just the big buzz in the industry right now. Why is that? Well, there's a few legitimate needs. There's a lot of completely illegitimate needs. All-flash arrays are extremely fast. They are the fastest that you can be. Your equivalency of a supercar. They have extremely low latency, so you get the fastest storage at the lowest latency. They normally don't have that large of a capacity, though. A lot of this has been changing recently with improvements to MLC, with TLC, but they're still not that large as a whole, especially not if you start talking about 7200 RPM storage. They tend to be a lot more expensive per terabyte as well. So where you might only pay a couple $100s for enterprise grade traditional spinning storage, for this you might be paying thousands of dollars per terabyte. It's not always the case, but it is often. Because of this expense, a lot of times with all-flash arrays, software is used to increase their capacity. I put this in quotes for a specific reason. It's usually using technologies like compression and dedupe, which essentially trades off CPU cycles for extra capacity. The trade-outs for this are kind of unknown. You don't know how much additional storage you're really going to get. Some vendors claim they will guarantee a 7-to-1 dedupe and compression ratio. So you'll get 7 times the amount of storage that you actually physically own, which would be great if that was actually the case all the time. But if you have a lot of pre-compressed video or pre-compressed images, things like that, a lot of times those ratios might be closer to 2-to-1. So when you're trying to size all flash arrays, it can be kind of difficult in that regard, because you don't know exactly how much you're getting if you're relying on those extra software features. Because of that, these arrays have had very surgical, precise uses over the years. So for example, my main production line of business app database might need extreme performance. So I'll put that one database out there on all flash, and that will allow that database to get the most performance it can possibly get. But if my problem isn't necessarily that database, it's everything, it's the whole ecosystem, all the supporting servers. A lot of Oracle deployments, you're looking at 30 to 100 servers to support the entire deployment. If that's the case, simply putting that one system on flash may not fully fix my problem. The surrounding ecosystem, the landscape, may still have performance concerns. Another place where all flash has really been put into place recently is VDI. People are saying all your VDI all the time, 100% should be on flash, which isn't necessarily the case, but a lot of people have been pushing that way. When it comes to VDI, there's very specific places where you really need extreme performance. But as a whole, the VDI entirety doesn't necessarily need the blistering fast performance. We'll talk about that a little bit more later as well. In the last few years, there's been a real change in trend on this to where all flash is for everything. All these vendors are saying, oh, well, with all our compression dedupe, with all these features, with all those features, you can just use Flash for everything. Why would you not put everything on it? Don't you want everything to be fast? Honestly, my 12 terabytes of archived TIFF images that I write once and then never read again, no, I don't care if that's fast. But for everything has kind of been the big push recently. And a lot of that comes down to those extra software features on top to try to make it be more economical. Another big thing you'll hear from pretty much every vendor is all flash is the most reliable thing ever. Nothing's moving in the entire box, so therefore nothing can fail. Well, not really the case. If you compare things, flash is still reasonably in its infancy compared to spinning drives. Flash has technically been around for like 30 to 40 years, but realistically it's only practically been in the mainstream for about 4 to 5 years. So it's got a lot less back-end history with its reliability. So a lot of the things we're making right now, we're still trying to figure out ways to compensate for Flash's shortcomings. So while it can be much more reliable, it's not intrinsically that all Flash 2.5-inch drives are going to be equally as reliable and that they're going to live as expected. Additionally, it's still not that there aren't any moving parts. You still have fans, you still have other things like that that are spinning in these. So just because they got rid of the spinning platters doesn't necessarily mean that all of the reliability issues go away. But this is something that has been greatly improved on. The instances of SSDs just randomly, without any warning, completely failing have definitely been going down over the years. This can make them require less maintenance. So all this stuff is all relative to the implementation of the system. One thing that's really obvious with all flash arrays is most of the products that aren't simply shoehorning flash drives into existing arrays are from startup companies. Companies who have only been around a few years. Everybody's heard of Pure Storage, for example. They just make a huge splash every year at VMworld, and Nimbus Data and these other people. Those guys are all reasonably young startups. They've been around a couple years, but nothing like your established players who have been around for 15 years and such, like XIO and your big EMCs and IBM's HP. Those guys have been around a long time. But a lot of those bigger vendors didn't get on the flash bandwagon early, so they didn't start developing their product early on. Instead, what they ended up doing is buying one of these other startups. So Cisco bought Whiptail, EMC bought Extreme.io, IBM bought TMS. You have all these big companies being late to the technology game. So rather than fixing it, they simply bought somebody who had already gotten there. So that can work well for them, but there's a lot of assimilation and support issues and other things when you take a company and bring them in, rebrand them, and then try to make them your sole option for something. So we have one more poll question on this. Are you using all flash arrays? And are you considering it? So it looks like most people aren't using it, but a large portion are considering it. A very small percentage of our people actually are using them right now, which is pretty much what I expected. As a whole, these are still very expensive items. So it's normally still either used very surgically or with companies who just have very nice IT budgets. So moving down the spectrum in regards to extremeness and newness, as it would be, we then have hybrid arrays. Hybrid arrays are a mix of our traditional spinning drive arrays and our SSD-based arrays. Normally the way it's configured is there's a small amount of extremely fast storage and then a large amount of slower storage. So rather than say, all right, all of my database has to be on super fast storage, I can just put the parts of it that need to be on fast storage there. Or not all of my images need to be on fast storage. Some of my images are 12 terabytes of archives, like I mentioned earlier. Let those 12 terabytes of archives sit on slower storage. Only put the things that need the SSD on there. Be very surgical in the way that it's used. Hybrid arrays are often improperly designed. This is one of the concerns with hybrid arrays. They often require more architecture to achieve the correct ratio of flash to hard drive. Some customers, they only need 0.1% of their storage to be fast to be able to compensate for the entirety of their workload. They don't need to have everything fast. They don't even need to have much fast. But if they can get 0.1% to be substantially faster, it compensates for all of their major problems. On the other side, some customers need a larger percentage. They might need up to 20% of their storage to be on flash. They still don't need everything. The rest of it's very stagnant, but they need a much larger percentage. And trying to work out what percentage of the storage people actually need on flash often leads to some improper designs. And that can cause hybrids to have a very bad actual practical implementation. A lot of that also leads back to different companies have different ways of actually migrating storage between the flash and the spinning drives. That difference can mean that only once a day, for example, things are migrated up to faster storage or slower. Or it could mean that every day things are migrated up based on the entire day, but still only once a day, or maybe twice, so it happens right in the middle of the day. These are usually the most cost-effective per terabyte per I/O in the industry, because the stuff that really needs the performance gets the performance, and the stuff that doesn't. So these tend to be the most cost-effective to get that high performance without having to buy all flash arrays. As mentioned, most environments, it's usually 10 to 30% of the data is active and warm. Out of that 10 to 30%, it might be a very small percentage that needs SSD levels of performance. It might be that 10 to 30% needs some form of performance, but a very small piece of that actually needs the high performance. So all of that can make these hybrid arrays very cost effective and still give amazing performance. Another place in traditional storage arrays that have hybrid components that can cause a lot of problems is the performance gap between different levels. So if I have all SSDs as my tier 1, but then I have a bunch of 8 terabyte 7200 RPM drives as my tier 2, everything that's in that cache is extremely fast. But if I miss something, say I write my data for the whole month, and then as I approach the end of the month, I get to end of month reports, and that data isn't any longer on my SSDs. If I have to go all the way down to massively large and slow 7200 RPM drives, that performance gap can be huge and really impact my entire environment's performance. So that's one of the things that you really need to watch for when looking at hybrid arrays. You want to make sure that your differential between the gaps isn't so massive that if you miss SSD for some reason, that it's just unusably slow. And this is another thing that you run into a lot with a lot of the startups now, is that they have pure SSD at the top and then as slow as they can possibly find, large as they can find, storage below. And that can really just cause a lot of performance issues in your environment if you don't properly architect everything from the very beginning. So the differential there between the 7200 RPM and SSDs can just make a massive impact. Using flash for cache is often called a hybrid by many companies, but it's not really. So flash for cache is something that everyone started to do a couple years ago. So they put this flash everywhere from in the actual host server itself to in the HBAs itself, all the way up to in the actual storage array itself. So they're sticking the flash everywhere, but they're using it simply as a cache. They're not using it to actually be permanent storage for anything. A lot of your ZFS-based storage arrays, all your Nexenta type things, use flash just for cache. It isn't a permanent storage repository. Because of that, what happens is storage propagates up to that flash when needed, but it doesn't permanently reside there in any way. So if anything happens that clears that cache, such as a firmware update or a reboot of a controller for some reason, or anything like that, it has to repopulate that flash. When it repopulates that flash, the first hits are going to be slow. They're going to be the speed of the underlying disks. So from the standpoint of these caching environments, how often that has to repopulate varies greatly depending on how it's implemented as a whole. So if the flash is local to the ESX host or local to the HBA that's in that host, that flash can conceivably be emptied very frequently. I take an ESX host down for maintenance. I vMotion a VM to a different server. Something like that can instantly blow out my flash cache. So all of a sudden, this cache that I've been relying on, this pure SSD performance, goes away. So that can be a big problem. So flash for cache can offer some serious improvements, but always be cognizant of the downsides of it and where the potential pitfalls are. Because there's a big differential between it and an actual hybrid array that permanently puts storage on different load areas. Some workloads may not be a good candidate for hybrid arrays. We'll talk about this a little bit more later, but certain storage workloads just don't lend themselves to having small portions of the database or what have you warm. They tend to access all of the data set, so the entire database gets hit all the time. Those might not be good candidates. It might be that no storage is particularly faster or slower than the other. Another thing with hybrid arrays is they're used often as a way to re-add performance into cheap and deep storage arrays. So we mentioned ZFS earlier. ZFS is a perfect example of this. They almost always recommend going with slow drives, putting flash in front of it. A lot of your other big players in the market right now are all going this route. Let's just put SSD in front of our cheap and deep and make it feel like it's faster. So how many of you actually have hybrid arrays now? We got a poll question will pop up for a minute. How many people are currently using them in some shape, form, or fashion in your environment? So it looks like most people aren't using hybrids right now. So it's actually a little surprising, just because they have been around for quite a bit longer and are becoming more and more prevalent. I have one more question to go along with this, is what is your estimated storage capacity? Go ahead and throw up a quick poll for that one just to see where we are. And so far, it's looking like most people are under 50 terabytes, with a small percentage being over 100, but most seem to be falling into that 50-ish terabyte range. Okay, so more of our smaller end customers with a few enterprise customers out there. Excellent. So something that is a trend in the mega enterprises. So this is your Googles, your Microsoft, your Amazons, other very large companies are going to more of a converged storage. So converged means a lot of different things, depending on where you are. The most generally accepted definition is essentially treating storage and compute as a single building block. That doesn't mean your Nutanix style all-in-one box. It simply means a building block, such that every single time that I want to buy any storage or compute to expand my environment, I buy X SAN array and X ESX hosts. Doesn't matter what I'm doing, I tend to always buy those type of blocks. Like I said, mega data centers like Google and Microsoft and Amazon, they do this because their workloads are very uniform. It's different within each customer, But as a whole, if you average it out, they can build out these building blocks that are very functional for their environments. What this does is prevents you from having to have a single mega monolithic SAN. So rather than having to keep going up the model numbers from Hitachi or something until you get to the VSP and then having to pay your hundreds and hundreds of thousands of dollars every year for support, you can scale out in smaller pieces. Those smaller pieces give you smaller failure domains. So if any one fails, it takes a very small impact rather than the entire of your organization. It can also help from a cost standpoint. Generally speaking, the larger the array, it's not a proportional cost increase. Things get much more expensive for the larger guys, even the same components. So it can potentially be your lowest cost option, as well as your lowest latency option. The lowest latency comes from geographic proximity. If you have a large monolithic SAN, you have this central place and you have switches connected to it, and you might hit 2 or 3 switches before you actually get back to that central SAN. All of that adds a little latency. If you do converged storage, it's local to that. Your small pod that you've built out with storage and with compute, that small pod has local fast access to the storage. There's also what's called hyper-converged. This has been making a big splash with EVO Rail from VMware, with vSAN that they were pushing. Datacore is an option with this, as well as Nutanix, of course, is the daughter child of all this. The storage and compute in the same box. So this allows your growth mechanism to be a single server. So if I want to add more VDI boxes, I just go buy this box. It comes with all the storage I need, it comes with all the licensing I need, the software I need, the compute. Everything's in that one box. Again, this is really good for scaling out. If I know exactly what my workloads are, what the size of my environment is, how all this stuff plays together really well, then if I do small boxes like this, it can be a very easy to budget environment. I'm about to land this large customer. I need to deploy X servers. I'm going to go buy X hyperconverged boxes. And it can be very, very easy to get your scale out model laid out very quickly with an easy budget number. The problem is if you aren't a really big customer, this can be very, very hard to do. If you're a smaller shop, say you've got between 50 and 100 servers, which based on storage I think is where the bulk of our group is here, then having to scale out in these set mediums can be very, very difficult, because one week I might be adding a new web server. Well, that doesn't need much resource. So my hyperconverged or my pod for that wouldn't be that large. However, the next week I might be doing an Exchange 2013 upgrade. Well, at that point I need a lot of resources, and I need it disparate, so I might need multiple pods to be able to separate that. So it becomes difficult for smaller customers to really fit into this converged storage mechanism. It can cause a lot of issues from the standpoint of how you scale it and when you scale it. And all of this can somewhat lead to vendor lock-in. So what do I mean by vendor lock-in? Well, everything can be subject to vendor lock-in, especially your monolithic arrays. But when you're putting all of your storage and all of your compute and your software all on one vendor's platform, getting away from that vendor can be very difficult, because it's not like you can go, I'm mad at HP servers. I'm not buying any more HP servers. Every server from now forward is going to be a Dell server, or every server from now forward is going to be IBM, what have you. That's fairly easy to do when you decouple everything, but once you get into these converged environments where you're buying, for example, an XIO chassis, Dell servers, and switches with every single implementation, then it could potentially be more trouble to get away from. That's one of the places where building blocks are very, very important. So you want to make sure that as you're looking at this solution, that you design it in a way that you can change out any part of the product at any time. So some use cases for all-flash arrays. There's several of them. They're often very specific. So all-flash arrays are really necessary when your entire working set is hot. I've got this 250 terabyte database, something massive, but the entire database is hot all the time. It's not that we ever leave anything in the database that's old. We've got this massive, massive, massive database, and all of it's always hot. Well, that's a problem because you've got to make the whole database hot. There's no way you can make some of it slower than others. So that's where all flash can really come in. I need everything to just always be very fast. Certain pieces of VDI, your golden master images for VDI, those guys are absolutely pounded when it comes to reads. They are read from all the time because every single VDI implementation in your environment reads off those same master golden images. So that can be very, very I/O demanding, especially on reads, and they can tend to be rather random as well. So that can be another place where all-flash arrays may make sense. One of the really nice things about XIO's implementation is since all the pieces are small building blocks, we can take and put a small all-flash array just for our master images and have more of the rest of our VDI stored on maybe a hybrid, so only the parts that need the performance get it. You can be very surgical in your use of all-flash arrays, which is something the industry as a whole is kind of missing right now, is that surgical implementation of products where they're needed. Another place where all-flash arrays really make a lot of sense is when you have a requirement of consistently guaranteed low latency. So it doesn't matter how often I access this data. I may not have accessed it for 4 years, but when I do access it, the speed at which I can access it has to be extremely rapid. I need 0.1 millisecond response times no matter how old the data is. That's a great place for all-flash. You run into this in a lot of big laboratory environments where they run tests and they conduct all kinds of experiments, and this stuff doesn't happen that often. But when they're running all these theoretical modelings and different things like that, they need it to be low latency regardless of how old it is. That's another place where you just can't get past all-flash array performance. Because even with an excellently designed hybrid array, you still have a bit extra latency when you go to the extra disks. Depending on how it's implemented, that could be, oh, instead of 0.1 milliseconds, I have 2 milliseconds of latency, which for normal folks is completely and utterly imperceivable. But for certain parts of this, like those massive databases where only small pieces are accessed rarely, that might not be acceptable. So performance requirements are more important than budgets. I throw this out there simply because all flash arrays are more expensive. Right now, flash is just more expensive, period. There are a lot of developments that are coming across for things like TLC and other improvements that are making flash much more dense at a cheap price, but those are still in development and testing. They aren't fully in production yet. So for right now, all flash is more expensive. And because of that, a lot of times, when it comes down to it, if somebody's like, no, this has to be all flash, we have to have the performance. I don't care what the budget is, it needs to be all flash. That's another place where we run into this, where it just has to be fast. It has to be extremely quick all the time. Doesn't matter the cost. Got a quick little picture here of some of the places where you traditionally see this. So your traditional RAID, your SAS arrays, hybrid arrays, and all-flash arrays. So a lot of places where you see SATA anymore, well, you're seeing it for everything. But where it really, really makes the most sense, backup archive, data that's not being used regularly. Routine file serving. I'm just serving out some files to users. It's nothing high performance needs. It's just some spreadsheets, some Word docs, some other things like that. That's a good place for SATA storage. Microsoft technically supports putting Exchange on SATA. Wouldn't recommend it. that's still something that, even though they have greatly lowered the performance footprint, would still look at putting it on SAS, which is why it kind of spans those two areas. Traditional SAS arrays, and when I say SAS, let's be clear, we're talking 10K drives, 10 or 15K drives, not nearline SAS. Nearline SAS are 7200 RPM drives. They perform the same as SATA drives. There's no difference in their performance. It's simply a different interconnect. This is another place where a lot of vendors are selling some FUD is, oh, well, we run SAS as our backend. We don't run SATA. No, we don't consider running SATA. We only run SAS. Okay, what speed? 7200 RPM. Well, that's the same as SATA. At the deep level architecture, when it gets down to SAS expanders and how it actually addresses and everything else, yes, there are some differences between nearline SAS and SATA. Realistically, from a performance standpoint, unless you have a massive, massive array, they pretty much perform identically. So always make sure you're keeping track of what the vendor's saying, not just from a, oh, well, we're using this technology, but how they're implementing it. SAS arrays are also good for a lot of rich media serving. This is another place that can span between the SATA and the SAS arrays. So if I'm doing 4K video, 4K video can be hundreds and hundreds of megs a second of data, but it's all sequential. It's a sequential read, sequential write, and then just sequential reads after that. It doesn't necessarily need that random performance. So that can perform very well on slower storage. It doesn't necessarily benefit much from hybrid or all flash because you're in such large quantities of data. Hybrid arrays, this is a good place for, well, we covered it, anything that needs some high performance but not everything high performance. So a lot of your VDIs don't need everything to be on all flash. It works very well when part of it is on all flash. And then all flash arrays. All flash arrays, again, trading desks. So if you're in high frequency trading and stuff like that, yeah, all flash, definitely without question. Extreme OLTP environments, yep, all flash might make perfect sense. Online transaction processing, that's what OLTP stands for. Business intelligence, doing data warehousing, where you're pulling in a lot of data and it's all being processed real time. You're always pulling all the data in, pushing all the data out. OLTP can be great. Sorry. All flash arrays can be great for that type of stuff. And of course, with all this, with the increasing capacity and increasing performance comes dollars. So the largest and fastest arrays tend to cost more. The fastest arrays, all flash, with lower capacity can be quite a bit more expensive. So hybrid arrays. Use cases for these. Most everyone is the use case for hybrid. Almost everyone would be a good candidate for a properly designed, well-architected, well-implemented hybrid array. So almost everybody has that mission-critical part of their environment. For some people, it's a SQL database behind their line of business app. For other people, it's a few file shares where they just write and read very quickly from some files. So that might be their most important thing. But for pretty much everyone, there's something in their environment that's hit quite a bit more frequently than everything else. And most people have no idea what that is. So this is where hybrids, properly architected, intelligent hybrids, can really perform well. If you don't know what part of your environment needs that performance, a hybrid can find it for you and accelerate it for you without you having to know. So you put everything on your hybrid array and it intelligently figures out what it needs to move from flash to SAS or from SAS to flash or however it needs to. So for most people, this tends to be the best bang for their buck. Another places that we end up seeing a lot of hybrid arrays is people who don't have a problem. So their environment's performing okay on what they currently have, but they're about to buy a new environment. They're getting ready to get some new storage. It's getting end of life, what have you. So they want to get something that's going to give them the most performance they can get without breaking the bank. This is another great place for hybrid. I'm not having a problem, but I really would like the safety net of having some flash storage there, having something faster in case my workload changes. Maybe we added new database workload, Oracle EBS, for example, in a few months that is crazy performant. If I have this ahead of time, I can be ready for that. I can compensate for it when it comes. Or maybe I just want my end users to have the fastest experience possible. So even though I'm not having an issue with my traditional array, let's add some flash just to kind of pad it. Again, this tends to be the best ROI for most companies, return on investment. As a whole, a little bit of flash goes a long way in pretty much every customer environment. So having at least some flash can make a massive change to the entire way the environment works and how it functions. Finally, we're going to get to converged storage use cases. As we mentioned, converged are predetermined build-out sizes, so this can be great for very large companies. It's kind of difficult for smaller companies unless they're pushing heavily on the VDI side. You'll hear a lot of things like a V-block is a big one of these that you'll hear a lot. Every time you need storage and compute, you just buy this whole rack. The rack comes with a NetApp or an EMC in it. It comes with switches. It comes with servers, be they Cisco or HP or whoever. So that's kind of for those larger customers. As I mentioned earlier, most of the customers on this webinar seem to be smaller, but as a whole, converged usually applies for the bigger boys. So it allows for some flexibility within these predetermined growth units, though. So let's say I have these pods. Maybe I've standardized that my pod is a whole rack of storage and servers. So maybe 10 ESX hosts and a storage array, and then some switches to go with it. If I standardize on that, it doesn't mean that I necessarily have to keep buying that same product. I can change those pods. So maybe my EMC is not performing well, my NetApp, whatever I've got in there. I can replace that with an XIO array, for example. Maybe I build the pod that doesn't perform well because it's all SAS-based storage. Then I can add in an all-flash pod later that has extremely fast storage. But again, this whole pod methodology kind of is for bigger customers. So customers who are deploying hundreds and hundreds of servers. The biggest thing, again, with all the converged is predetermined growth size. So I need to deploy servers. This is how much it will cost. This is what I'm going to buy. Hyperconverged can be good for large scale-out deployments of a very uniform design. Hyperconverged is where you tend to get into more vendor lock-in. So if I buy Nutanix, for example, and I'm buying all these boxes, they all come with the Nutanix software, the VMware, or the hypervisor software, everything like that. I'm kind of now locked into working with Nutanix and their stuff. If I want to change and get rid of their stuff, well, now I kind of have to manage the old stuff through their window, new stuff through my own. Same thing with some of the EVO rail and other things. Maybe I say, I'm kind of tired of VMware. The cost savings are going to be huge if we go to Hyper-V. Well, that can be difficult with these hyperconverged because most of them are built specifically for a particular implementation. So if later on you want to change it, it can be very hard. This can be a big problem for even VDI deployments. Maybe I'm switching around how I want my storage laid out. Maybe I'm getting denser and denser because I'm getting more and more clients on each server because servers are getting more and more powerful. Well, maybe at that point I don't have the best implementation anymore for what I previously had. Maybe because my hosts are getting bigger, I need to get faster storage to be able to back the same number of hosts moving forward. And again, this can be very useful for large-scale VDI deployments or remote office branch offices. So I've got 50, 60 sites. I just want to send a single box to those sites. I don't want to have to worry about sending some type of storage array, then some type of ESX box, and some other things. I just want one box. Well, hyperconverged would be great for that. I grab this one little box, it's got all the storage, it's got everything in it, I ship it out there, I'm done. My branch offices are finished. So, quick poll question before we move on. What storage do you guys currently have? Got a few of the normal offenders out there. Wow. And it looks like in this environment, very few people have the usual suspects. We're looking at about 25% EMC, 25% XIO, and about 70% everything else. So, So what other storages are you guys using if you're not using the normal suspects? Are you using direct attached storage, just in your ESX hosts, data core? Who are you guys using if not the big guys? Okay, so some HA DAS environments. So that would be like a small HP MSA that just direct attaches over SAS or a Dell. Data core, another DAS, some iSCSI Dell, data core. Sounds like a lot of data core customers. So, speaking to all that, let's talk about XIO. XIO has a very interesting place in the storage market. They aren't a new up-and-comer. They've been around for, I'm sure the XIO people will shoot me for not knowing, 15 years, around that number. They've been around for quite a while. They obviously haven't been around for the 30 years of some of the really big guys. They've been around for a long time. The other nice thing is since they aren't a mega corporation like your EMCs and NetApp, they can be very flexible and agile in their product. Many storage vendors simply just stick flash in their existing systems. This was a big thing that HP and EMC did for a long time. They didn't re-architect anything. They just took the same form factor, 2.5-inch flash drives, and stuck them in their existing arrays and started running them. And that worked really well for them, actually, for a little bit. But then once they got past a certain number of drives, all of a sudden their controllers just couldn't keep up anymore. Their controllers couldn't push the throughput needed to be able to compensate. So that caused a lot of limitations within the environments. So yeah, I know you bought the biggest array we have, and I know you're only using 25% of the capacity we rated it for, but since you put these SSDs in, you have to buy new controllers separate from these if you want to keep spanning. So that's kind of been a problem with flash. It's been so fast that it's broken other parts of the environment. Which leads to a few things that XIO's done to really help themselves not fall victim to the same flash problems that other people have. One is XIO is a grid system. They build everything in small 3U enclosures. If I need to push out one 3 terabyte array, I can buy that. I can buy a 3U enclosure that has 3 terabytes. I can get that in all flash in a hybrid, or I can get it in simple traditional drives. If later on I find that I need some really fast storage, well, I can buy an all-flash array. Again, small or larger. And I can operate these side by side. There's never a case where all of a sudden, oh, that investment you made last year for that spinny drive, yeah, sorry. We're going to need to forklift and throw that away and replace the whole thing. So this grid system allows them to put flash in where necessary, but not force you to buy it everywhere, or force you to overbuy your environment. Another thing to compensate for this is XIO redeveloped their product from ground up to accommodate and use flash. If you've heard from us in the last 3 or 4 years, XIO hasn't had a flash product. They haven't. Everybody's asking about it, and we're like, nope, there's no all-flash product. They have hybrid products, but no all-flash products. And the reason for that was they didn't want to rush and improperly implement an all-flash array. So they went back to their product, they improved their controllers, they improved their design to really beef up the environment to be able to properly provide an appropriate all-flash array. Another reason they were a little bit later getting to the all-flash environment is they didn't need it for a lot of customers. The way XIO's hybrid arrays work is they're extremely granular and responsive. Rather than running once a day to tier storage up to their faster tiers, so once a day we figure out all of our storage usage for the entire day and then move stuff up to flash. Rather than doing that, let's do it every 5 minutes. Let's do it every 30 seconds. So they're extremely granular and responsive, and they do it very intelligently with ROI calculations. So when I start seeing that something is performing fast and it needs to be faster, XIO will actually do a small ROI calculation. They'll figure out, okay, it's going to take me some cycles, it's going to take some IOPS to move this from my traditional storage up to my all-flash. Is it worth it? Is the performance increase going to be enough? Yes or no? If yes, it will move it up. If no, then it won't. And this extremely responsive and granular hybrid array has led to not needing all-flash in most every environment. Another place where XIO really excels, especially with flash, is I mentioned earlier, flash is still in its infancy. It's still not mainstream. It's getting there, but it's still new. We've only had a few years of flash really being in enterprises, but spinning disks have been out there for 40 years now. So there's a big difference in how mature the products are. That leads that sometimes SSDs can just fail, just without knowledge or anything else, just die. And this is where XIO's self-healing managed reliability really comes into its own. So if you've been on some of the other webinars or talked to other Mirazon employees or other XIO people, you've heard about this before. Within these XIO chassis, they can essentially self-heal drives. They can load diagnostic firmware onto drives. They can do testing of the drives to see how happy they are. They can make adjustments to how these drives operate in the field without having to take them offline. They can do low-level formats. They can reset drives, which is kind of like walking into the data center and pulling it out and putting it back in. They can do all this stuff in the box without having to be user intervention at all. It just works, is what it's often called. We ask customers a lot, can you give us a testimonial for XIO? You've had it for like 4 years, and they're like, I'm sorry, I really don't have anything to say. You put it in and it's just ran for the last 4 years. We've not done anything with it. It's just worked. That's perfect. That's the best testimonial ever. And with that, with all of this managed reliability, with all this special approach that XIO takes to the environment, they've developed their product to give guaranteed performance. When you buy an XIO system, day one, it performs the exact same as it will when it is 99.9% full. Getting around a lot of the cliffs that people tend to run into with storage arrays, where it performed really well, but the longer we run it, it keeps getting slower, and the more storage we put on it gets slower. And we called up NetApp, and they said, oh, well, that's because you're 70% full. You need to buy more disks. XIO doesn't work like that. When you format the array, that is what space you can use, and it will all be just as fast. So you don't have to worry about short-stroking drives or anything like that. It just works, and it works at the speed it's supposed to. And we've touched on this a few times, but it's extraordinarily important. So I want to make sure I say it again. Their grid approach is huge. Being able to deploy these units in small 3U enclosures, where if XIO doesn't perform, you can throw them away. If a year after you buy it, you don't like it, don't buy anymore. Buy somebody else next time. Don't keep going down that path. It means that they have to do their stuff really, really well, because if they don't, you're not stuck with them. You're not forced to buy more of their stuff. With these small 3U enclosures, you can buy what you need when you need it for that particular use case. So rather than having to buy for 5 years of storage usage, you can buy today an all-spinning drive or a hybrid array. And then if you start doing something massive, like some big ERP system or some big a new hospital records program or something like that in a year, rather than having to redesign your whole SAN, you just buy a new chunk, a new building block, a new grid piece that focuses on that particular use case that you have, that particular thing that you need addressed. These blocks are all the way from 3.6 terabytes usable all the way up to 36 formatted usable terabytes in 3U. So a very large range of products that you can work with. So you can buy exactly what you need when you need it. And this can be extremely important, especially for smaller companies. Bigger companies tend to have massive budgets, so they can do whatever they want. But with smaller companies especially, not overbuying, not getting stuck with high maintenance bills, things like that is extremely important. And speaking of maintenance, 5-year hardware warranty out of the box. So no surprise, oh, you've exceeded these controllers, we need to upgrade your controllers. We'll do that for only 20%. Oh, okay, that's nice. But your support's going to double. Ah, that's not cool. So 5-year hardware warranty out of the box. Any hardware issues whatsoever for 5 years, fully covered, no problems. And then something that's just a single bullet point on this list, but is pretty huge, the Storage Performance Council, the unbiased adjudicator of storage, if you will, the people who test everybody's different storage in very preset environments and run this storage with the exact same tests without any changes. XIO just won the lowest cost per IOP of all storage arrays. So it doesn't matter who they are. They are the fastest for they are the cheapest for their performance of anybody. And it's not that this performance was slow and that's why they're cheapest. It was an extremely fast response time as well. So this is a huge thing. XIO as a whole in the enterprise space is very cheap compared to the other products. And I don't mean cheap as in the, oh, well, this is kind of chintzy. I mean cost effective rather than cheap. So we have one more poll question. When are you considering new storage? Is this something you're actively looking for right now, or is this something that you're just kind of here to see what the landscape is, figure out what's going on? And as you're doing that poll question, ask questions. Finished about 5 minutes early, it looks like. So if anybody has any questions, start asking, and we'll answer some questions. So from the poll, it looks like most people are here just pretty much to learn what's out there. They're not looking to buy for a little bit of time, but they're curious. They want to know what the environment's like, which is perfectly fair. Few people have immediate needs, but as a whole, stretching out. So questions? Bueller? Bueller? So someone asked about Mac video editing. So when it comes to Macs, they're special. I think we all know this. They're special little snowflakes. The Mac video editing as a whole, there aren't a lot of good products in general out for that right now. Since Apple quit producing pretty much all of their enterprise products, there aren't a lot of things for that out right now. What's basically happened to the environment is it's fragmented. The environment's fragmented where we now have people making software that works well with Mac video editing, and then people making the back-end storage that goes behind it. So one of the big software companies is Quantum with StoreNext, big for video editing. We've got some large customers using that. But then the back-end storage behind it can pretty much be whatever you want within certain parameters. So that's where it really depends on what your storage needs are. XIO offers some very cost-effective large terabyte options. At present, as a whole, they don't play in the air quote cheap and deep environment, so the massively, massively cheap places. But if you're looking for something for real-time editing, where you have a lot of editors hitting it, it would definitely perform extremely well in that environment behind software that's developed for it. Any other questions? What connection options are available with XIO? That's a very good question. We can do fiber channel. We can do all the traditional fiber channel options, 2, 4, 8 gig fiber channel. We can also go with iSCSI. We can do 10 or 40 gig iSCSI. So if you're looking for either environment, you've got options. One key thing with regards to fiber channel that has gotten a lot of customers in on XIO, even at small shops, is they have 4 fiber channel ports per controller in each 3U chassis, which means if you've got a small environment, you've only got 2 or 3 ESX hosts, you don't grow a lot, you can buy a single 3U XIO chassis and direct connect all 3 of those hosts to the XIO. You don't have to have any fiber channel switches. You don't have to deal with zoning. You don't have to deal with firmware updates. You can simply direct connect and run directly off of that XIO unit and not have to deal with all that other environment. Granted, if you want to do any of the really nice features like synchronous mirroring, I want to have 2 ICE chassis, and those 2 ICE chassis mirror everything in lockstep to each other. Well, then I need switches because I need those hosts to be able to talk to both of those chassis. But for small customers, Direct Connect can offer a lot of benefits. So that's all the questions we have right now. I'd like to thank everybody for joining. I'll hang around for another minute or so just to see if anybody has any last-minute questions. If not, my contact information is down in the bottom of this last slide, brent.earls@mirazon.com, as well as our phone number. So feel free to call us and ask any questions you may have. Thanks, everyone. So I did get one more question, just for those people who are still around. Is the pricing in line with Dell, QLogic, etc.? So it really depends on what type of storage you're buying from those. Dell, HP, all those first-party vendors, a lot of what they do is OEM, other people's products. So it's not actually a Dell chassis. It might be an LSI chassis, and they put their pretty little badges on it. If that's the case, a lot of times you can get extraordinarily cheap in that front. But that's also not an enterprise array. So if that's what you're looking for, just the cheapest things that Dell offers, then no. You honestly probably aren't looking at apples to apples price comparison. However, if you're looking for the higher end Dell products, some of the higher end compellents, the compellents that are actually more of an enterprise product, where you've got your 2 controllers, you've got your failover, you've got your actual software features, your enterprise products, then the price can be very, very similar. So if you're talking the cheapest storage array you can get, probably not a direct comparison. But if you're talking anything other than the cheapest array you can get, it can be very competitive. Again, they do have the lowest cost per IOP of anyone in the storage industry right now. All right. That was the only question we got. So once again, thanks everybody for coming, and talk to some of you later.